In part 3 of the lecture, we will be looking at what we call as determining sample size, and we will look at determining sample size for the mean and also the proportion. To calculate sample sizes to reach a desired margin of error with a specified level of confidence 1 minus alpha. The margin of error is also called a sampling error. What is sampling error is the amount of imprecision in the estimate of the population parameter, the amount added and subtracted to the point estimate to form the confidence interval. Okay, for determining sample sizes, this margin of error is very important, which is given here, x bar plus minus z alpha divided by 2 sigma divided by square root of n. So the margin of error is actually this component here, E equals to z alpha divided by 2 sigma divided by square root of n. So how do we determine the sample size is by using this part here, E z alpha divided by 2 divided by sigma divided by square root of n. When we solve this to get n, we will get n equals to z alpha divided by 2 to the power of 2 sigma squared error squared. So to calculate required sample sizes for mean, you must know first is your level of confidence, which is given by 1 minus alpha, which will also determine the critical value of z alpha divided by 2. The acceptable sampling error, which is your E, and the standard deviation, which is your sigma. We will now look at how we calculate sample size for a given particular situation. In this situation, the population of download times for a particular video file has a standard deviation of sigma equals to 25 seconds. A random sample is taken. What is the sample size needed to estimate mu within plus minus 5 seconds with 95% confidence? So we will use this formula, n equals to z squared sigma squared E squared. So your z for 95% confidence is 1.96. Sample size is 25. Error is plus minus 5, right? 5 to the power 2. So you get a number 96.04. So the required sample size cannot be smaller than this. So it will be slightly higher. So n will be 97. Always round up to the next number. If sigma is unknown, the sigma can be estimated when using the required sample size formula. Use a value for sigma that is expected to be at least as large as the true sigma value, or select a pilot sample and estimate the sigma with the sample standard deviation. So when we determine sample size for proportion, this is your formula, error equals to z square root of pi times 1 minus pi divided by n. We will solve this to get n, z alpha divided by 2 to the power of 2, n times 1 minus n, error squared. So this is the formula that we will use to calculate sample size for proportion. To determine the required sample size for proportion, you must know the desired level of confidence 1 minus alpha, which also determines the critical value of z alpha divided by 2. Then we must know the acceptable sampling error, which is your E, and the true proportion of events of interest, which is the pi. A pi actually can be estimated with a pilot sample if necessary, or conservatively, you can use a pi equals to 0.5 as an estimate of pi. Okay. How do we calculate the required sample size in an example like this? How large a sample would be necessary to estimate the true proportion of sales invoices containing errors in a large population within plus minus 7% with 95% confidence? Assume a pilot sample yields your P equals to 0.15. So to solve this problem, confidence interval 95%, Z alpha divided by 2 is 1.96, E is 0.07, P equals to 0.15. So once we substitute into this formula, 1.96 to the power of 2, 0.15 times 1 minus 0.15 divided by 0.03 squared, you get 99.96. So when we round it up, we will use an n equals to 100. Next, I'll walk you through an exercise which is given in page 330, exercise number 7, exercise 8.39. If the manager of a paint supply store wants to estimate with 99% confidence the mean amount of paint in a 1 gallon can to within plus minus 0.005 gallons, and also assume that the standard deviation 0.045 gallons, what sample size is needed? So as usual, we will write the formula, and since now we are at 99% confidence, for the critical value for 99% is 2.576, or you can also round it up to 2.58. The sigma is 0.045, so squared divided by your error squared, we get 537.5, so we round it up to 538. So the sample size needed for a 99% confidence interval is sample size needed is 538. I have also given you exercise number 8, which is from exercise 8.49, page 331. You can do it on your own, and later I will post the answers on the e-learn. So what are some of the ethical issues in the calculation of confidence interval? Confidence interval estimate should always be included when reporting a point estimate. The level of confidence should always be reported 95%, 99%, 95%, or 90%. The sample size should also be reported, and an interpretation of the confidence interval estimate should also be provided. So how confident are you that the mu value will be within the lower limit and the upper limit? So finally, the chapter summary. What we have covered in this chapter is we have discussed the construction and interpretation of confidence interval estimates for the mean and also the proportion, and also how to determine sample size, which is necessary to develop confidence interval for the mean and the proportion. Okay? That's the end of this chapter. Thank you.